Hello, my name is Peter Todd and my lab partner is Andrew Mickey. This is our video report for Lab 8 Lasers in OPTI380 at the University of Arizona's Wyant College of Optical Science. This lab builds on our previous optical experiments but now focuses on the lasers themselves, specifically their alignment, modes, and spectra. We began by aligning a helium-neon laser cavity that used several instruments, the Fabry-Perot spectrometer, optical spectrum analyzer, and electrical spectrum analyzer to explore the characteristics and mode structure of laser light.
So for this part of the lab, we first used our green laser going through the gas tube, and we adjusted our mirrors to make sure the light went through this so they were aligned. After they were aligned, we turned off our green laser, then we turned on the gas tube and adjusted the tilt screws on our mirror here until we got lasing effect that created different orders of results.
In part B of the lab, we used a Fabry-Perot spectrometer to observe the longitudinal modes of the helium-neon laser. We measured the time space between major fringe groups, and our observed value resulted in a 1.3% error compared to the theoretical value. Okay, so for part C of the lab, we start with our source, and we aligned these two mirrors and the source so that it hit this detector here, which showed us the graph of the emission into power per wavelength of the source that we're choosing, either the laser diode or the LED. And what we did we found this here is our mode, and using this dial here, we found the peak of the mode for our central mode, and then we found to either edge of the side for the width of the mode. And then also for the other source that you can't see here, we had two separate modes, so we found the distance between the two central modes for both of them, the central wavelength for both of those modes. In part D, we measured beat frequencies from the photodetector with an electrical spectrum analyzer. With a cavity length of 23.5 centimeters, our expected longitudinal mode spacing is 0.638 gigahertz, just like in part B. However, on the ESA, we observed only two close-together peaks that resulted in a separation of approximately 0.19 gigahertz, giving us an error just north of 70%. We believe this large discrepancy is likely due to an instrument or setup issue, as other teams were having issues with this part. Overall, this lab gave us hands-on experience with laser alignment and spectral analysis. And it was fun. Thanks for watching.